So this is workplace 36.2, multiple transformations. All right, so we'll do a little bit of review working with parallel and transversal lines. So you remember parallel and transversal, right? So if we have two lines that are parallel and we have a transversal, a line that cuts them, we do have some angles that are the same and stuff like that, right? So let's just read here. Often when a shape or object undergoes a transformation, it undergoes more than one transformation. So let's find my pen here. With more than one transformation, it may be rotated, then translated, for example, or reflected over the y-axis, then translated. So there's going to be some order of things that we're going to need to do. So when we have to enlarge, rotate, and translate an object all at the same time, what we want to do is we want to try and do the rotations and the dilations first. So the stretches and the enlargements and that sort of thing and the rotations, those ones we want to do first, and then think about the sliding, the translating, okay? That's probably going to be the best way to go about this. So on the following coordinate plane, do the following transformations. Rotate the shape 90 degrees clockwise about the origin and draw the resulting image. Translate the rotated shape 4 units to the right and then 3 units down and draw the resulting image. What are the coordinates of the vertices of the final image? Okay, so you do have this in your handout there. You have the solution, but before you look at the solution, let's just see what they're talking about here. So rotating it 90 degrees clockwise. So remember, a clock goes like this, right? This is the direction a clock goes, from 1 to 2 to 3 and so on, right? So this is clockwise, and when it says about the origin, that means around the origin, or having the origin as the pivot point, okay? So now if you had a transparency, an overhead transparency, you know, like that blank transparent paper we used to put on the overheads, if you had an arrow drawn on there, and you put your finger down real hard and you slid the paper around, that would be like a translation. So literally it would be, you know, let me see, this calculator, right? And you would rotate it around and it would just spin around the pivot point, wherever that pivot point is. So 90 degrees about the origin, okay, 90 degrees clockwise. So that means that every point has to go 90 degrees. And remember, a 90 degree angle would be like this, okay? That's a 90 degree angle. So imagine this has to go, let's say this right here this is the line through the arrow. You don't have to do it this way, but 90 degrees from that line through the arrow would be over here. And so this arrow is going to have to be spun around to here, okay? So let's think about this. If we go 1, 2, 3, 4 units to the left and 1 unit down, this line right here is 90 degrees with this line right here, the y-axis. So 4 left and 1 down becomes 4 up and 1 over. Okay, do you see how this point right here becomes this point? That's a rotation of 90 degrees. Or if you were to connect, watch this, if you were to connect this point and the origin and the new point, it should form exactly 90 degrees. You see that? So every point should have that little relationship. Does that make sense? So let's follow this through and see if that works. So this is B prime, I guess, right? B prime. So A prime is 1, 2, 3, 4, 5, 6 units to the left and 1 unit down. So let's go 1, 2, 3, 4, 5, 6 and 1 down, and there's the other point. So here's the side, or the bottom of the arrow. And then you could go right from here, I guess you could kind of start counting, and I'll change my color. 1, 2, 3 to get to G. So you could go 1, 2, 3 to get to G. So that's G prime, right? And so on, and you could go over to F and 1 unit and so on. And so you could start building the arrow sort of this way, right? Whoops, like that. Okay, so that's how it's rotated 90 degrees. Everyone see that? But you take it from here and you rotate it up 90 degrees in the clockwise direction. So we went from here, right? And we went clockwise to here. Got it? All right, so that's the first one. And then draw the resulting image. Okay, so here it is. And then what we're going to do is we're going to translate the rotated shape 4 units to the right and 3 units down. So we'll use a different color yet. And 4 units to the right for each one. 1, 2, 3, 4, and 3 down, 2, 3. There's your new one. That's a double prime there, right? And then it's the same, whoops. It's the same, faces the same direction and everything like that. So we've got 2 units, we've got 3 units, and so on. 2 units, okay? So you just go ahead and copy this. 4 units to the right and 3 units down. So let's take a look at our solution on the next page and see what happens. Does that look pretty close? Does that look pretty close to what I had? Yeah, it does look pretty close to what I had there. So that's where we'd be. Okay, so you could draw it like that, and then you could identify the new points. Okay, so let's see what they did here. Okay, A to A prime. Okay, so you see how they flipped these around? Now this might be a little difficult to picture just if you look at the numbers like this. Okay, so this is a rotation of 90 degrees. I would encourage you to, like we did, to draw it out. 1, 2, 3, 4, and then down 1. So go 1, 2, 3, 4, and then over 1. So do that, and then you'd see that this would be a -6, -1 point, and this is a -1, +6 coordinate. Okay, so just going from point to point, you might have to sketch it out. Okay, you might have to sketch it out or whatever. So I'm a visual guy here too, so a lot of you guys are visual learners on that, so you might have to just kind of sketch it out. All right, no problem in doing that. Okay. So that's what that looks like. So as we move on, let's do a build your skills question here together. And move that over just a bit. So rotate the following shape 270 degrees clockwise. Okay, so let's say we have our x over here, right? So 270 degrees clockwise, well, this x right here is going to go 90, 180, 270. So that x is going to rotate around this way almost 1 full time around, 3/4 of the way around. Okay? So imagine this is the pivot point, and every point is going to go around, 1/4 way around, half the way around, 3/4 of the way around. Right? So think about this. Let's do like this point right here from the origin. Okay? Is going to be 1, 2, 3, 4 units over and 1, 2, 3, 4 units up. So if we went 180, this would be easy. We go 1, 2, 3, 4 this way, 1, 2, 3, 4 this way. But we're going to go 3/4. So we're going to go another one. 1, 2, 3, 4, 1, 2, 3, 4. So it looks like it's going to be, this point right here is going to be translated, going to be rotated, sorry, down this way. Okay? So all these points are going to go, and all these sides are going to go down like this. So this x is going to be, I guess, looking like, it's pretty symmetrical, so it's going to look, I guess, just like this. So where is that going to be now? It's like that. It's a bit on the tougher side to draw, I would say. Well, not sure why they did an x either, I guess, but.
Could have done an
Something like this. These, they don't really match up very nicely there, do they? Anyway, so it looks like that. So this has gone from here. That's 90 degrees. Down here, 80 degrees, 180, and then here, 270. See that? It's kind of flipped, rotated around. So it kind of looks like itself there. All right. And then what? Translated 2 units to the right and 3 units down. So 2 units to the right. So this side, if you want to view that, goes 1, 2 units, and then 1, 2, 3 units down. So that little side of the x right here is moved to down here. 2 units to the right and 1, 2, 3 units down. So everything goes 2 units to the right and 3 units down. And then you can just redraw that x there, I guess. Okay, so we've rotated around 270. This whole thing has been rotated around 270 and then moved 2 spaces to the right and 3 spaces down to give the red one. Okay? So that red image is the one we're actually looking for. Okay?
I have a question.
Yes, question.
What does it mean by show the intermediate step?
So, okay, very good. Thank you for asking. Show the intermediate step. So that means you have to show this outlined X as well. So don't just show the final red X in this case, show the intermediate one too. And if you want to use like a little dotted line or just shade lightly with your pencil and then fill in the final version, that's great too. So just show kind of, just like in this last example, I guess they're saying, show the intermediate step. So there's an intermediate step and then there's the final, see? So show all the steps, yeah. Okay. Awesome. Okay, so there'll be some more there for you to do. I'm going to get to the next example here, and I'm going to just kind of fast forward. You have time to finish some of those questions a bit later, but let's continue this lesson here. This one talks about now reflecting again. So if you could follow me here and move to page 244, we'll just go over this example. So this one has multiple reflections now. Okay, so this one says reflect the shape over the y-axis. There's the y-axis. And then over the x-axis, and here's the x-axis, of course. So we're going to flip it, okay? We're going to flip that this way, and then we're going to flip it this way, all right? So we're going to flip it this way around the x-axis, and then we're going to flip it this way around the, y-axis, then x-axis, okay? So let's zoom in here a little bit so we can kind of see this a bit better. So if everything was reflected on the x-axis, that means that this is like the mirror, right? The y is like the mirror. So this b is 2 units from the mirror, so let's take it 2 units on the other side. A is 1 unit from the mirror, so let's take the a prime on the other side, you see? Same distance. We got the c up here. And some of you are really good at visual perception and artistic ability, and you could probably get this really easy. 1, 2, 3, 2, 3. So I kind of have to make sure I do my counting and stuff. I'm going to connect the points as well here just to make sure that I'm doing this kind of right. So that looks pretty good so far. F over here is 3 units away, so I'm going to take it 1, 2, 3 units away as well. Connect A and F prime. Okay. So is this looking okay to you guys here? This E is on the axis, 1, 2, 3, 4, 5 units. So I'm going to take it on the axis, 1, 2, 3, 4, 5 units as well. So connect all those lines. And there you've got your first reflection about the y-axis. Then what we do is want to reflect it about the x-axis. Now, the x-axis, it lies on the x-axis, so it's kind of like it rotates on itself a little bit. So there's going to be, the reflection is actually on the actual on the actual shape. So that's no problem. Let's do the reflection in red. Well, this F is 1 unit away from the reflection line. So let's take it 1 unit the other way. So there's F double prime now. This A is 2 units, so we'll take it 2 units. So there's A double prime. So F is connected to A just like F is connected to A. And B is 1, 2, 3, 4 units away from the reflected line. So 1, 2, 3, 4. So on, we'll connect A and B double prime as well. So you see how this is working out here? 1, 2, 3 up there. So 1, 2, 3 there. And C is 1, 2, 3, 4, 5. Like this. So C and B are connected. C and D are connected here. And then look at this point. This is very interesting. This point right here, E double prime, right? Or sorry, E prime right here, is on the reflection line. So guess what? It doesn't move. If it's on the reflection line, it does not move, and it's the exact same point. So E double prime and E prime are the same point. That's a bad line there. Poor drawing. It's a poor drawing. There we go. So now your red is your final version there. It's been reflected twice. Do you know what this looks like to me? It almost looks like this original shape has been rotated 180 degrees. Boy, I wonder if that's the same.
I thought you could say something.
Look, it looks like it's been rotated 180 degrees. If you reflect something in the y-axis and then reflect that thing in the x-axis, does that become a 180 rotation every time? I wonder. Let's do a little experiment. What's this point right over here? That is 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6. Okay, so this is negative 8, 6, okay, that point. Now if I reflect it in the y-axis, 1, 2, 3, well, that's 6 units, so 1, 2, 3, 4, 5, 6. And then reflect it in the x-axis, 1, 2, 3, 4, 5, duh. That should be 8 over here. Duh. And then 6 down here, 1, 2, 3, 4, 5, 6. Does that look like a 180 degree rotation here from that point to this point?
Yes.
Is it straight through the origin? Wow. That could be something there, hey? Let's just see. Is there a straight line connecting this point? Oh, wow. This point and this point, does that go right through the origin? It absolutely does. So if you reflect something in the y-axis and then in the x-axis, it appears, now I don't know if this can be a mathematical proof because we've tried it twice, but it appears that it's the same as a 180 rotation. So keep that in mind, and as you work through this, I want you to see if that comes up again, okay? Because that's something that we've just stumbled upon. And in math, it's actually really cool when you can, you're working on something and then you see something else. Because there's so much interrelatedness in math that there's a lot of patterns that make connections. Okay, so we might see that somewhere coming up. But I think that's pretty cool. Okay. All right, build your skills. So I'm going to let you guys kind of do this on your own. If you need some help, I'll help you. But please work on the second part, or I guess this is the only part, of 6.2. So there are build your skills questions here as well. And so I want you to work on questions 1 to 8, please. 1 to 8, and to get those done for this class here. So you can get that done by the end of the class, okay?